Anti-differentiation. Objectives. By the end of this lesson, you should be able to define an antiderivative and understand its relationship to the derivative of a function, and then evaluate improper antiderivatives. Okay, so the whole idea of this is we're going to kind of go backwards from derivatives. So like a good example is one Ivy loves to do. Suppose you were given a velocity function, right? How would you find the position function? How do you go back to the position function? Well, that process is called antidifferentiation, or more commonly known as integration. That's what I like to call it too. So that's the whole idea right here, right? So if you have a y or f of x and you take a derivative, you're gonna get dyx or f prime of x. If you want to go backwards, it's called antidifferentiation or integration. Right? So that's the whole idea. We're gonna kind of go backwards. We're gonna be given a derivative and we want to go back to the original function. So let's talk about the notation. It's one of the coolest notation in mathematics. So that's the notation for integration. We kind of talked about that more last time, right? It's kind of an S because it means the sum, which is because integration is area the curve. But that's so when you see that symbol, that means integrate. So you're gonna go back to the original function. Now, when we integrate, a lot of times we'll say the derivative is a lowercase f of x, and then the original function is uppercase. And then we always have to add this plus c here when it has no limit, and we'll talk more about that later. But what's that about? Well, let's think about it. Let's say I give you a function like f of x equals x squared plus 2. Let's take a derivative. Right, bring it down, subtract 1 off, derivative constant goes away. So that's my derivative. Now if we want to integrate this, if I said, hey, let's integrate, oh, that is an ugly S. Let's integrate. Oh, man, it is not easy to write this. Let's do it over here. Oh, we're rolling. We're keeping this live. That's the best I'm going to do. So we're going to integrate 2x dx, right? So let's integrate that. Now, we haven't talked about the methods yet, so that's all that today's about. But we already know what it is. We integrate, we go backwards. We know that the opposite of this is x squared. Now, how do you get that 2? That's a constant, because that could easily have been 2, could have been 4, could have been 5. Right? No matter what, I put whatever constant I put here, the derivative is going to be 0. So I have no idea what constant could be there. So we always just put plus c, because that could have been a 2, it could have been a 5, it could have been a 0. So to just make sure we know what we're talking about, we'd always put a plus c to catch that constant. That is called the constant of integration, or the integration constant. So that's the way it works. Let's go over our first rule. Our first rule, just like what we learned with first in derivatives, is the power rule. So the power rule for integrals. So the general idea is this. The derivative, bring it down, subtract 1 off. On integrate it, you're going to add 1 to the power and divide by a new power. That's the rule. So if you integrate something, you add 1 to the power and divide by a new power. So let's do a quick example right here. Right, so I have x squared, I have the integral of x squared dx. So I'm just going to add 1 to the power and divide by new power. So I get x cubed over 3. Don't forget plus the constant, because who knows what was before that. But that's our answer. Right, simple integration to add 1 to the power, divide by a new power. Right, if we do another one here, I'm going to integrate x to 3/2. Oh, a little more annoying because the fractions. So you add 1 to the power, so common denominator. I'm going to get x to the 5/2. I can divide by the new power. Or 5/2. Now I can't leave it like this, that's ugly. Easiest thing to do, there's a shortcut. That bottom goes to the bottom one right here, goes to the top right, because you're dividing by this, so you multiply by the reciprocal. Just this moves up. So you get 2 x to the 5/2 over 5 plus the constant. Let's do one more before we hit our next rule. Now this one, kind of like how we did differentiation, I could still integrate that, I just got to rewrite it. So first I'm going to rewrite it as x to the -2 dx. Now we're just going to add 1 to the power and get -1. So it's x to the -1 over my new power, -1, plus the constant, or if you want to make it prettier, -x to the -1 plus c. Or if you want to make it even prettier, -1 over x plus c. So there you go, right? Any one of those would work. But that's the power rule. All you do is add 1 to the power and divide by new power. Now let's talk about a couple other rules. First one's one of my favorites. If you integrate a constant, So integrate constant, you just add the x. We're just going backwards, right? So think about it backwards. If I give you 2x, the derivative would be just 2. So if you want to go backwards, if you have a constant, just add the x to it. So like, for example, if I give you integral of 3 dx, that integral will be, just add the x, 3x plus c. The integral of e dx, it's just e to the x, right? Remember the derivative of e dx is e dx. So when you integrate, just go backwards, you get the same thing, right? We love our e's. So the integral of e to the x is just e to the x plus c. Man, I almost messed that up. Now the next one's more of a memorization one. Now all these are in your formula sheet, so it's fine. But if you remember from back before when we did the I gave you natural log of x, its derivative was 1 over x. So the integral, of course, is the opposite. So if you see the integral of 1 over x, the integral of that, you go, oh, it's just more of a memorization. Like, it's natural log of x. Now they put absolute value there because you can have a negative inside of it. So it's a little. Again, that is on your formula sheet, so you just copy it. Likewise for sine and cosine, integral of cosine is sine, right? Because the derivative of sine is cosine. The derivative of cosine is so. Again, these are just in your formula sheet, so let's just look on them. So the integral of cosine is just sine, and the integral of sine is just negative cosine. Now, right, switched. Normally, cosine gives you the negative. This time, since we're going backwards, sine is when it's giving you the negative cosine. So those are all the basic integrals we're going to talk about today. Again, all of them are in your formula sheet, just like right here. Right, so there's a power rule. The natural log one, sine is negative cosine, cosine is negative sine, and e to the x. A couple more rules that are not in your formula sheet that we actually use a lot. First is the sum difference rule. Just like taking derivatives, you could separate an integral. So if I give you integral like integral of 2x plus 1 dx, you could break it up and do the integral of 2x plus integral of 1. Oh, that's ugly. Integral of 1 dx. There we go. So you can separate, just like a derivative. Separate, take each one separately. Sometimes it's easier to do this, sometimes it's not. And then another one that's actually super powerful is you can pull out a constant. Because a constant, just like when we take derivative, a constant doesn't really do anything. So if I say, oh, we want to integrate 3x squared dx, you can just pull the 3 into the front because it doesn't do anything. And just integrate this. So let's try those. Right, first row here. See, like this one, we can actually do both rows together if we want to. We could separate it. Now again, we really don't have to, but we'll just do it for prosperity's sake. And then we could, if we really want to, we could pull out the 3, the constants. Then we can integrate this. Remember the way you integrate it? You add 1 to the power, divide by a new power. It's a power rule. So I'm going to gain 3 times x cubed over 3 plus, I forgot the 2 here, the x here. Integrate x, you add 1 to the power, divide by a new power. There's already a 1 there, so I get this. 2x squared over 2 plus c. You know, right? You could just do it for the whole thing, not just for each one. These cancel out, and you just get x cubed plus x squared plus c. Again, that's an extreme case. I just wanted to show you use all the rules. Normally, we just integrate it. Like, this one's easy enough. Now, there's definitely times we're going to do this, but this one's so easy. You can just add 1, divide by a new power, add 1, divide by a new power, and you could have got x cubed plus x squared plus c right away. But there will be times where you do want to know how to use these rules. Okay, just a couple other ones. This first one, we'll just do the basic way. Really shortcut, right? Just go, okay, it's all power rules, so just do each one. Add 1 to the power, divide by a new power. Add 1 to the power, divide by a new power. And then that's just a constant, so you just add the x. Don't forget the plus c, and that's our original function. Now this one, right, so it's a little more complicated. So this one, I'm actually going to separate it. I'm going to integrate x to the negative 3 dx minus the integral of x to the 1/2. Just like taking derivative, you want it as a fraction. Dx. Again, I don't have to. It's just I think this one is actually a little easier if you just try to take each one separately. So on this, I'm going to add 1 to the power divided by new power. X to the -2 over -2 minus add 1 to the power, which gives me 2 over 2, 3 over 2 divided by my new power. Remember the shortcut? Just move the 2 to the top, so you don't have like a complex fraction on there. And then don't forget the plus c. Right, so it's just straight up power rule. It's all we're doing. That's for these two. That was a little fancier, just like we did in derivatives. Make it a fraction, add 1 to the power divided by new power. Just like we did in derivatives, move it up, and then to negative, and then just do add 1 to the power divided by new power. Now let's look at this one. So we want to integrate this, so let's integrate this. Now again, if you want, you can separate it, but most of the time we just kind of picture that we're separating it. It's like on here. Remember that 2 doesn't do anything, so just integrate sine, which is cosine, negative cosine actually. So that'll be -2 cosine x. Then integrate cosine, which is just sine, so keeps the negative. Dx. Ooh, dx, sorry. Plus c. That'll be my answer. Now again, if it makes you feel better, you can always separate it. Integral of cosine dx. I notice I pulled a 2 out already. And then integral of sine is just negative cosine. And integral of cosine is just positive sine. If you're not sure, just look at your formula sheet, they're in there. If you simplify it, you get this. This one I will separate, because again, it's a little messy. So let me separate this. So I'm going to integrate the first one. Again, notice, actually I'll talk about it in a second. Okay, I'm getting too math excited. Plus integral of this one. So on this one, I think it's actually really helpful if you pull out the constant. So let's pull out the -2. Then we're going to integrate 1 over x dx. Hope you see why it's a lot easier. Over here you can pull out the 3. Integral of this, that's just natural log, right? It's kind of hard to see it right there, but now, it's just natural log. So this is going to be -2 natural log absolute value of x plus integral of e is this e, 3e to the x, and then add the constant. And that's how you do those. Right, so all this has been just using the basic rules. We have a power rule for integration, and then we have all like the small basic rules, one for sine and cosine, the ones for e and natural log, like just the memorization ones that are in your formula sheet. Now I'm going to do something a little different. We've been using this constant c, right? Now sometimes I'm actually having you find c. How do I know when I want you to find it? If I give you a value, if they ever give you a point or a value here, like cf of 0 equals 2, it's the same thing as saying the point 0, 2. If you're doing integration, they give you a point, it's to find c every single time. So if they ever give you a value like this, or they give you a straight out point, they want you to find c. So let's look at this problem. Find f of x, the original function, given the derivative. So they give you the derivative, they want you to find the original function. Remember the way you go back is we integrate. And my S's are getting slightly better. So let's integrate. Now look at this one, straight out power rule. So just add 1 to the power, divide by a new power. Add 1 to the power, divide by a new power. Now again, remember that's a constant, you just add the x, and don't forget the plus c. So I'm going to get x to the 4th. So my original function equals x to the 4th over 4 minus 2x cubed over 3 plus 3x plus c. Right? I found my f of x, just like they asked. But there's a constant here, so I got to find that constant. And again, like I was saying over and over again, right? If they give you this, that's how you want you. Then you know they want you to find it. So how do we do it? Well, that's an x and that's a y. Right? So you plug it in and find c. So we're going to plug in 0, 0, 0, and then 2. They made this one easy. C is 2. Now that's not my final answer. The question wasn't to find c, like it wasn't directly to find c, you had to find it though. It's to find the function. So my actual answer is f of x. Right, plug your c back in. X to the 4th over 4 minus 2/3 x cubed plus 3x plus 2. That's the final answer. Let's do it again. Right, so same idea, find f of x given this funkier equation, and then they give you a point. So again, if I see that, I'm like, oh, I gotta find c. I gotta find c. So, same concept. Okay, I have the derivative, so I gotta go back to my original function where I integrate. See, those are slightly better. I'm lying to myself. So, if we integrate this, now again, I'm gonna separate that because it's a little easier. So I'm gonna pull the 2 out already, because I'm pro like that. Subtract, integrate, x to the 1/2. Ooh, so pro, but we have the dx. There we go. Now it's proper notation. But the dx just lets you know what variable you want to take the derivative of. When you get to like advanced mathematics, you'll have like different variables here. Same way, integral of sine is negative cosine. Right, it's in your formula sheet, so I'll just put negative 2 cosine. Integral of x to the 1/2, you just power rule, add 1 to the power, which is 2 over 2. So 3 over 2, and divide by a new power. Remember the shortcut, bring the bottom to the top. So minus 2 x to the 3/2 over 3 plus c. Hopefully you can write nicer than I can, because my original function is now this. Right? Almost done. I still got to find my c, then I can rewrite my whole equation. And again, they give you a point here, x and y. Got lucky again to plug in 0. Plug in 0, plug in 0, set equal to 4. So this is just 0. Here though, I gotta remember what cosine 0 is. Now there's 2 ways you can do that, guys. One way to use your chart, there's actually lots of ways you can do this. I'm gonna use the chart here, 1, 0. And cosine's the x value. So 1. You can also think about the graph. Graph of cosine starts on top. So it starts at 1. Or you could do the chart thing, freaks. So 4 equals, this is going to be 1. Negative 2 times 1 plus c. So 4 equals negative 2 plus c. So c equals 6. And again, that's not the answer. The question was find the actual function, so plug your c back in. So my answer is going to be f of x equals negative 2 cosine x minus 2x to 3/2 over 3 plus 6. That's the answer. Okay, one last problem. Now this is the same concept, it's just the fact that, notice they give us the second derivative. I mean, they had to go back to the original function, so we have to go up twice. We have to integrate twice. And notice they give us 2 points. So basically we're going to do the same thing we just did, just 2 times, because you got to go back to the original function. So that's the kind of process. Let's get to it. Right, so again, they want me to find the original function given the second derivative. So let me integrate this, integrate both sides. I'm going to get the first derivative, because you only go 1 up. Add 1 straight out power rule, add 1 to the power divided by any power. So 4x cubed. That's a constant, so you just add the x. Plus c. Now, first thing we gotta do before we integrate again is find that c. I guess technically you could integrate again, but I think it's a lot easier to just find the c first. So let's find the c. So we're gonna use, I have the first derivative, so let's use this one. Here's my x, here's my y. So plug in 0, set equal to 3, negative 1, I don't know where I got 3 from. So negative 1 equals c. So my equation is gonna be the first derivative is gonna equal 4x cubed minus 4x minus 1. Now, I gotta get back to the original function. So let's take the integral one more time. Integrate this, go back to the original function. Again, straight up power rule, add 1 to the power, divide by any power. Ooh, nice. Add 1 to the power, divide by any power. Nice again. 2x squared, and then that's just a constant, so you add the x. Don't forget the c. And again, just like before, you got to find out what that c is. So let's go back. They tell us in the original function, which is what we have, that when you plug in 1 for x, you get 4 for y. So this is 4. We're going to plug in 1 for all these. And we're going to get 4 equals 1 plus 2. Remember, you do this first. So 1 times 2 is 2. That looks ugly, but that's just 1. Oh, 1 times 1 is 1. That's a 1. Ignore it. Shield your eyes, kids. to 1. Plus c, these cancel. 4 equals 2 plus c. So c equals 2. Again, the question wasn't what is c, we actually had two c's. The question was what's the original function? So plug your c back in. F of x equals x to the 4th plus 2x squared minus x plus 2. And there we go. We are done with the basic rules of integration.